be solving an easy LC problem 2379, that is minimum recolors to get k consecutive black blocks. Let's read the problem first to understand it better. We are given a zero index string blocks of length n, and each element in the blocks is either W or B, and W denotes white, B denotes black. Let's see this. Okay. I have taken a block string as WB, WW, BBW, and here W denotes white and B denotes black as per the problem. And we are also given an integer k, which is the desired number of consecutive black blocks. We here have an integer k. Okay, and in one operation we can recolor a white block such that it becomes a black. Okay. Next, we have to find the minimum number of operations needed so that we get at least one occurrence of k consecutive black blocks. So the k here we have chosen is 2. So our goal here is to find two consecutive elements, and those two consecutive elements should be only black, not white. Let's say we choose this two consecutive element. Here we have one white and the other is black. So we have to do the recoloring operation as stated here. We can recolor white block to a black one, right? So we can recolor this white to a block, and the number of operations we are performing for this particular window is 1 because we have a one white block. Let's say we choose this window. Here the number of white block is 2, so the number of recolor operation we have to perform here is 2 because we have to recolor this white to black so that we get k consecutive black blocks, right? But if we choose this window, here since already the two elements found in this window are black, we don't have to perform any recoloring at all. The number of operations we are doing here is 0. So out of all the windows, this one has the minimum number, that is 0, right? So this is the answer. This is what we have to find. Let's try to let's go through this problem pyramid, which would be really helpful when we are going through the implementation. The first aim would be we have to choose k blocks, like the window that I was referring to. Next, we have to recolor to make all black. If any of the elements in the particular window is white, we can recolor it to black, and each recoloring is considered as one operation, right? And we also have to note down the number of operations we are performing in each window. Out of all the windows, we have to find the minimum recolor operation. So the last goal would be, out of all windows, we have to find the minimum number of recolor operations we are performing here. And if we choose this window, the recolor operation we are performing here is 0, and this is going to be the answer. Yeah, here you can see. Let's try to understand the implementation visually first, and then let's start with the coding. So the implementation just consists of two steps, and the step one would be we will be creating a k size window, and then we are creating two variables. One is ands and the other is void. So what will ands store? Ands will store the minimum recolor operation that we have to return at the end of the program. Okay. Then we also have another variable void, and this will hold the number of white elements of the currently chosen window. Like if we are going to choose this particular window, then the number of white is equal to 1, right? Then white variable will hold the value 1. And if I am choosing this particular window, then the white will be assigned with 2. So this is how it works. Okay. Yeah, as I said, ands will be equal to the minimum recolor operation, and if you notice carefully, the number of recolor operations required for a particular window is equal to the number of white, right? Okay. Next, let's get into the step 2. Here in step 2, to explain this more clear, I have taken inputs k as 2 and blocks is WB, WW, BBW. Here, yeah, now I have created those blocks here based on the input. As I said in step 1, I have created a k size window, and this window can hold two elements at a time. Then let's iterate through each window, and for each window we will note down the number of recolor operation. At the same time, we will also update our answer. Okay, so let's start from the first index. In the first index, when I start from the first index, this is the first window I get. Here the number of white color elements is equal to 1, right? So I will update this void variable with 1. And I have already initialized the answer variable with 2, like equal to k. Now the number of recolor operation for this particular window is 1. Now what I will do is I will compare this 1 with the existing answer. Since the number of recolor operation I have to perform for this particular window is less than the existing answer, I'm going to update this answer with the current void color operation, that is 1. So what does this exactly mean? Now I have a particular window and the number of recolor operation that I have to perform is 1. So this is the minimum recolor operation that I have found so far. But we should not stop it here because we have like similar windows, so like many upcoming windows. So we will just continue our search. Next, I will slide through the next window. So this is the next window I get, like k consecutive elements. Here in this particular window, again the number of white color elements is equal to 1, right? 1. So I will just try to compare this white color variable with the variable ans, and since both are equal, I will not be updating the answer. Next, I will be moving my window slightly towards right. If I move my window slightly towards right, the number of white color elements here is equal to 2. So the number of recolor operations that I have to perform here is equal to 2. Should I update answer with 2? No, because we our final aim is to store minimum number in ans, and the existing answer is already less than 2, so I'm not updating the answer variable with 2. Then let's go to the next window. Here again the number of void elements is equal to 1, and the existing answer is already equal to 1, and we are not going to update it. Next I will just move to the next window. Here the number of void is equal to 0, and if I compare this void count with the existing answer, the void is actually lesser than the existing answer. So I have to update the answer with 0. What does this step exactly mean here? So we have finally found out a window where the number of recolor operation we have to perform is 0. That is very minimum so far. Next, let's try to move to the next window. But that actually makes no sense because answer cannot be less than 0. So we can actually end our implementation here. But I will just go through the remaining thing to like make it more understanding. Here, if I move to the next window, the number of white is equal to 1. Will I update the answer? No, because we have already found a minimum number of recolor operation that we have to perform. So the final answer that we will be returning after all iterations is 0. So this is a visual implementation. Now let's get into the coding part. Here in the step 1, we have to create a k size window, and we have to create a initialize variable ans with k and y 0, right? Let's do that. Before doing that, I am going to convert this string into a character array. The reason for doing this is just for efficiency. I will also create a variable n to hold the length of the string. Then as per the implementation, we can create a variable ans and another variable void. So initially void will be 0, ans will be equal to k. Yeah. Next, let's create a k size window. How are we going to do that? So I'm going to find the first k elements from the blocks. Like as we did here, I'm going to first find the I'm going to create a k size window that holds the first k elements of the string. And I will also find how many white elements are found in that particular window. Here I will be iterating through the B array, and I will keep count of the white elements. If B array of I is equal to W, that is if it is a white element, I am going to increase the white count by 1. Then okay, at the end of this for loop, I will have the white count of first k variables, like right, first k elements. here the void count was 1, right? After iterating to the first k elements, the void count would be equal to 1. Next, what we have to do is I'm going to update the answer. So if since the yeah, now the answer is initialized with 2, the void count we got here is 1. I'm going to check if the void count is less than the existing answer, then our answer should be updated, right? So answer will be equal to void. If not, we are not going to update the answer. Then let's try to what we have done next is we are shifting our window towards right. How are we going to shift our window? So to do the shifting of window, I'm going to start my iteration from k. I use less than n. If you look closer, like what am I doing exactly here? I'm increasing my window size by 1 and then decreasing the window by 1, like increasing in the right hand side by 1 and decreasing in the left hand side by 1. So same operation I'm going to do it here. Now I already have a k size window. Now I'm going to increase it in the right hand side. Increase in the right hand side. If the B array of I, that is the element that is found over here, if this element is going to be white, then I'm going to increase the void count by 1. So what does this line exactly means? So I have increased my window size by 1, because of which white will be updated to 2, and I will remove the element from left hand side, decrease left side. How do I do that? If the array of I minus k, so I minus k here would give 0, right? Since I is equal to 2 and k is also equal to 2, I minus k gives us the leftmost index of that particular window, and if the leftmost index is equal to white, I am going to decrease its count by 1. Now we have shifted our left hand by 1. Now we have found a new window, and this new window has void count as 1. Decrementing the void count by 1 at this stage will give 1 as the new value for this void variable. Now what am I going to do here? Now again I will be following this step. If the newly calculated void count is less than the existing answer, I'm just updating my answer, because answer should be holding the minimum recolor operation. Yeah, lastly I will be returning the answer. So this is how the implementation looks like. Let's run this and try. Oh, blocks.length. Yep, this is the implementation.